Good afternoon. My name is Mr. Chimanda. Welcome back to our lockdown school week 4. This week we are starting with a new topic. Which is trigonometry. So that is what we are going to be doing today. So let's get to it. Yes. So with trigonometry, you've done trigonometry before in your grade 10 and grade 11. So we are going to be doing what we call the double angle and the compound angle, which is an extension or which is just a continuation from there. So we are going to be doing the double angle, right? And we are going also to be doing the compound angle. We are also going to do like solving equations. We're going to be doing solving equations using these two. So we solve equations or trigonometric. So these are going to be trigonometric equations. So they're trigonometric equations, which we are going to be using to solve double angles and compound angles, right? We are also going to solving angles. So the first thing that we need to know is what is a compound angle, what is a double angle, and how do we implement the solving. So we start from here. So the first thing that we know about trigonometric ratios. So we have trig ratios. The trig ratios that we know is the tangent, which is commonly known as tan x, and we have the sine, which is just written as sine x. Then we also have the cosine, which is just written as cos x. So these are the three common trig ratios that we know. So an example, if we are given that sine x is equal to half, this is an equation. This one is an equation. So normally, if sine x is equal to half, we are going to we solve for sine x. But if we solve for x, but we solve for x on a particular range, right? Because we can have an infinity number of x's that we can get. But here we solve it on a particular range. Here we will always be given that. So find x where x is between 0 and 360 degrees. We're just going to quickly do a quick recap before we go into the compound angle and double angle. So with this one, you can easily solve this one and quickly say x is equal to shift sine half, which is also known as arcsine half, right? Where we can now take our calculator and punch it. We take our calculator and now we punch shift sine 1/2. And let me put it in degrees. Right. Put it in degrees. So it depends on how you want to calculate it. You want to calculate your x in degrees, or you want to calculate your x in radians. So here, let's do the simple one. We calculate in degrees. So it's shift sine 1/2. Then we get, so x is equal to 30 degrees. But that is not the only value that can give me a half if I put it there. Because if I say sine half, the sine 1/2, I will get, sorry, if I say sine 30, I will get half. If I say sine 30, I will get a half, right? But is it the only value that is within 360 that gives me half? So now we can, I hope you've done what are known as quadrants, right? Quadrants are the ones, right? Quadrants are the ones that we always use. I just want to quickly check. Okay, I'm just quickly checking if my connection is okay here. Okay, so now we continue. So it's either you use quadrants or you use graphs. So if you want to use the graph of sine looks like this. Passes through 360 here and 180 here. Here it is 90, and here it is 270. So you can actually see that my half is 2 points, which is 30, and so 30 it passes through 30, and here 150. So if I come here and say sine 150 half, right? So you will be able to, if this is how we have solved our trig functions all along. Right? This is how we have solved our trig functions all along, right? So that you are given, you can solve for x and solve for y. You can either use the graphs or you can use quadrants. You can use quadrants where we have 4 quadrants, if you're familiar with quadrants, right? Now, let's go to compound angles. Let's go to compound angles. The compound angles, what is a compound angle? A compound angle is in the form, if I have tan A plus B, or tan A minus B. 5 cos is cos A plus B, or cos A minus B. If it's sine, it follows the same, similar A plus B, or sine A minus B. All right. Why is it called a compound angle? If I come and draw, I come and draw a triangle like this. Right. Let's say this is angle A and this is angle B. Right? Angle A and angle B. So I have angle A and I have angle B. So now, if I look at it, right? If I look at it on this triangle, if I can find sine, let's say I'm using sine, I can find sine A using this triangle, and I can find sine be using this triangle. What about the sine of the whole angle? The sine of the whole angle. So this angle and this angle, if we add them together, they become what we know as compound angle. That's why we are saying A plus what? A plus B. That is what we mean by saying compound angle. We are looking, this is a different angle, this is a different angle. So if I combine them, rather than for calculating if sine this one and sine this one, and adding them together, that is not how we do it. We added them together and put them, and they now represent our x value. Right? So that becomes what is known as a compound angle. But how does this compound angle come about? I'm gonna explain, because we want to derive the identities of these compound angles. Right? Now, the first one we have here. So let's label our diagrams, which is x, y, and z, our vertices, right? And let's call this V. So we have A and B here, right? So let's call this side B and A. And here it becomes a 90-degree angle. So basically we have two triangles. Let's say we're trying to build a bridge. If you know Nelson Mandela Bridge in town, this is how it looks like. So we're trying to create a bridge here. Then you can actually see that the extension here is longer than the extension here. But it also works, let's say you want to create a stability. So what is the angle that you're going to put here and the angle that you're going to put here? We're not going to calculate this angle on its own and this angle on its own. We need a compound angle. So that is what we would use this compound angle for. So we're trying to derive it using this diagram. Right? So now, I'm going to put this diagram on the side and we can work with it. So if this is a right angle triangle, we can find the area of this triangle and the area of this triangle. So we can quickly come here and say the area of the whole triangle, the area of the triangle is equal to half A B sine C. That is the area of a triangle. It is given by half A B sine C. That is if we are given an A. So it means if we have a triangle with you know the two sides and an angle between, we're able to find the area of the triangle. Right? This I can quickly draw it here. If I have a triangle A, B, and C, and this side is small a, and this side is small b, so I am saying if I have this angle, I can find the area of this triangle if I'm given two sides and an angle between. So it's half A, B, sine C. So we are going to be using this. So we can come now here and now say we want to find the area of this whole triangle is similar to the area of this triangle plus the area of this triangle. So we are saying triangle, right? The area of the triangle X, Y, Z is equal to the triangle X, Y, V plus the triangle X, V, Z. So we've basically said the area of the whole triangle is the area of this triangle plus the area of this triangle. That is what we just said here. Right? But if you look at it now, if you look at it, you can see hello Eugenia.
Hello?
And there's only you in the meeting.
No, there are 27 attendees.
Oh, okay. So thank you very much. So now, if we look now, we are saying the area of this triangle plus the area of this triangle is equal to the area of the whole triangle. So how do we find the area of this triangle? Let's call this side H, right, as a height. So we have this side B, this side H, and this side A. So if we look at it, the area of this triangle is half BH sine A from this one, which is half AB sine C. In this case, it's a half BH sine A. So this one becomes half BH sine A. Plus, we are going to do this one now. Now, with this one, let's close this side. We have A and H and B in between. So we have half B. We have half A, H, because of A and H, and an angle between. Right? Which is what? Which is sine. Sine B. So I'll repeat again. I'm adding the area of the two triangles. So with this one, I have two sides and an angle between. With this one as well, I have two sides and an angle between. So it means I am now going to be adding the areas of the two triangles that are. But let's say I want to add the area of the whole triangle. The area of the whole triangle. I just want to find the area of the whole triangle one time. So I can now say this is my angle. But what is my angle here? It's A plus B, right? And what is my side? The other. So this is, the other side is B. The other side is A. So it's an angle between is A plus B. The other side is B. The other side is A. So here I'll write half A sine. What is the angle between A plus B? So we are saying half AB, which is the area of the whole triangle, when I'm finding it one time, right? When I'm finding the area of the triangle one time, I can say half A times B sine the angle between. The angle between is A plus B, which is equal. I can find them individually, which is this triangle, which is half B A times H, and the angle between is A, which is here, plus this triangle, half A H sine B, which is between, which is in between. So I hope you have understood this stage. Now let's move from this stage, right? From this stage, I'm going to eliminate A and B, A and B and H and whatever, so that I'm just left with sine. What is my A plus B equal? Suppose that's the common angle I'm looking for here. So I want to eliminate this one, AB. So I know that if I have half, I can eliminate half. That's fine, right? And here I have B, but I don't have an A. Here I have a B, A, and I have an H. So the honorable thing that we can do is to remove this, to substitute this H. Let's come here. So this is a right, these are right angles, right? So we can actually see that H in this case, if with respect to this angle, H is an adjacent and B is a hypotenuse. So we can come and say cos A is equal to, which is the H over B. So we can conclude that H is equal to B cos A. What I've simply done, right, this is B. What I've simply done is I've cross multiplied. So by cross multiplying, it becomes H is equal to B cos A. So I can now see that H is equal to B cos A. On a similar fashion, if I use this triangle, let's say I decide to use this triangle. If I use this triangle, it means that I am saying I'm looking at B. So B H according to the angle B is adjacent. I can say cos B is equal to H over A. So cos B is equal to H over A, which I can go and write now and say H. I can go now and say H is equal to A cos. So what I'm simply saying is I can find my H, this one, in two ways. I can find my H using this triangle, or I can find my H using this triangle. Both ways work. So here it becomes easier now that, okay, if I look at it, I want to eliminate half AB. And here I want to create something that will involve AB. So since I have a B already, I'm going to put something that involves A. And here I also want to create half AB, right? So if I put this one, it becomes A squared. I will not be able to eliminate half AB. But if I put a B, something with a B here, I will be able to give half AB, which I can now divide everything by half AB, and it goes away. So I can now come and easily substitute these two into this. I want to write it down. It becomes half AB sine A plus B. I'm simply rewriting this one is equal to half. Where there is H now, I substitute. Because remember, I have B already, right? I substitute. So I have B, and I substitute with H, which is A cos B sine A, plus here I write my half, but I have an A already. I want to have something with a B, so I'm going to take this one with a B, so it becomes B cos A, and I write sine B. Awesome. So what you can see now is I have created something that involves A and B on all the terms. So here I have A and B. Here I have half A and B, and here I also have half A and B. So by the principles of mathematics, I can now eliminate, I can now divide both sides everywhere by half AB. So I divide by half AB. So this one cancels this one. I divide by half AB, because BA times AB is the same thing. So I can cancel this one and half AB, because there is common everywhere. So now I can come and write down now. I can now come and write down neatly something that says, because I'm left with this. So sine A plus B is equal to cos B sine A plus cos A sine B. This is called an identity. So we have created, so this is the double angle formula, which says sine AB is equal to cos B sine A plus cos A sine B, right? That is what is known as double angle formula. So this, what everything that I've done here, you will not be examined about it. They're just trying to show you how is it derived, right? But this you'll be given in a formula sheet. You are supposed to know how to use this, how to implement this identity. So this is known as an identity. Identity. It's an identity. I think you are all familiar with identities from the previous one. So the previous trick that you've done. We have identities such as sine. Let me write with something that you can see. Sine squared plus cos squared is equal to 1. That's an identity, right? So basically, we are adding more identities. So this one is known as the compound angle formula or identity. We say sine A plus B is equals to cos B sine A plus sine A cos B. We can try to do an example to see if it really works. Right? Does it work? Is it true that if I use this formula, I will get this? So let's try one. So let's try sine 75. Is it really equal to sine 45 plus 30? So what I've done is I have split this 75 into 45 and 30, because 45 and 30, I get 75. So now I want to see, so if I say sine 75 on my calculator, sine, I'm just gonna quickly, sine 75, I'm gonna write it to three significant figures. It becomes 0.966. I've returned to three significant. So here I want to use the compound formula. Right? It becomes, if I use this one, so it becomes, so my A is 45 and my B is 30. So it becomes, this one becomes sine, was, let me come back here a little bit. This one I can write it as sine A cos B plus sine B cos A. I've just written this one so that because it is A, I'm writing it first, and this one is B, I'm writing it second, right? And here, I just want to make sure that my sign is at the first, since I'm using sign, is at the beginning. So it becomes sine A, which is sine 45, cos 30, plus cos 45, sine 30. So if I can punch it in my calculator here, or you have a calculator, let's punch it together, right? I'll have sine 45 times, or make sure, because this is the times, so you must always try to put bracket, right? Cos 30 plus cos 45 times sine 30. You see, I get exactly the same value, which is equal to 0.966. I get the exact same value. So what I was just trying to do here is just trying to prove that this one works. Let's try another one. Let's try another one. You have sine 60. Is it equal to sine 15 plus 45? I'm just going to give you 30 seconds to do that one quickly. Is it equal to that? Sine 60 is it equal to sine 15? So I want you to implement this one and use this one, punch it straight in the calculator. Sine 60 is equal to root 3 over 2, right? Root 3 over 2, or you can put it in decimal, which is 0.866 if I put it in decimal, right? So here, now use the double angle formula to check, does it give you the same? Right? That is what we are doing right now. Right? So if I use the double angle, it becomes sine 15 cos 45 plus sine 45 cos 15. So I'm just gonna punch it. So be careful with trigonometry. You must always be careful on how you punch it into your calculator. So me, I'm always careful. So I'll write sine 15, then I close the bracket. Don't forget to close it, times cos 45, right? Plus sine 45 times times cos 15. Which I also get as root 3 over 2, which is just as 0.866. So in basic essence, we have shown that we are able to derive a compound angle that can actually make it easier for us to calculate. Because now someone will ask, why should we split it to 15 and 45? Why when we can just write it as sine 60? Well, sometimes now you'll be given a sine A plus 20 is equal to root 3 over 2. Then now you are asked to find A now. So using this one, you cannot find A straight. But using what? Using the double angle formula, or you are able to find A. But I can take some questions now just to see if there's any questions. Right? If there's any questions or anyone who wants to ask something, feel free. Someone says, are we splitting it into two acute angles? Yes, if we check here, yes, we are splitting it into two acute angles, but even if they are obtuse angles, right, it does not matter, or even if they are reflex angles, as long as this is an angle, if we split them, if they are split already, right, you can actually use this to find the value on the value that side. But normally, in most cases, we use these to solve equations. Remember, when we started, we said we are going to be solving tricky equations. So we are going to be using those angles now, the double angle and the compound angle, to be solving. But now, remember, we said we have how many? We have 6 of them, right? We have tan is one with a positive part and the one with a negative. One with a positive, one with a negative. One with a positive and one with a negative. Right? So the one with the negative, I can actually explain it to you how it can work. Sometimes look at what is his name? Let's go to Mandela Bridge. Mandela Bridge is so many roads. So remember, we can do compound angles either by adding to see if the tensor or the structure is going to be stronger or not. So we can add, we will be playing with angles to see if I subtract a smaller angle or if I add a smaller angle, is it going to be more stable or is it going to be more stronger or less stronger or weaker? This is a concept that you can use in engineering. But for now, so since we have 6 of them, and I said proving them is not a necessity. We can spend the entire day or the entire week just trying to prove all the 3 or the 6 trig ratios. Right? We can spend the entire week, but it's not necessary because we are not allowed. We are not asked to prove them. What we are simply asked at this stage is for you to be able to use them given a question. So now I'm going to write all of them down. Right? I'm going to write all of them down, the trig ratios, which mostly they are given in a formula sheet. But a formula sheet is just there to, aid you. You must be able to know which one to use. Because if you are given 6 of them and you don't know which one to use, then it will be a disaster for you. Okay, so now the first one we derived is sine A plus B is equal to, so it's not always written as A and B, right? It's not always written as A and B. Sometimes it can be written as sine theta plus alpha, right? So as long as you recognize that there are 2 angles, that is the most important thing. So now we have, this is equal to sine A cos B plus sine B cos A. The next one is also about sine. So it's sine A minus B. So this one is sine A cos B minus. So you see, you don't take negative cos B. The only thing that is changing is the negative and the positive sign here. So here is sine B cos A. So this is for sine. For cos A plus B. We can, remember we said we don't need to prove it, but this is, after you prove it, this is how it will look. It will be cos A cos B minus sine A sine B. What do we notice? What do we notice? What we notice is that cos, if there's a plus, we get a negative sign. And cos is not like this one, which is sine cos. This one is cos sine sine. So you must always take note and be wary of that. That cos A plus B is equals, but the formula will always be given, so you don't have to worry. Then we have cos A minus B, which is equal to cos A cos B plus sine A sine B. So that's where you must always be aware that a negative gives us a positive. So if you come and say cos A plus B gives us cos A cos B plus, then it is wrong, right? But always, if you're not sure, refer to your marking scheme or to your formula sheet, right? Now we'll go to the one for tan. So tan A plus B is equal to tan A plus tan B over 1 minus tan A tan B. All right. So you can actually see that here tan, it gives like tan A plus tan B, but there's a negative sign. Right. Then here tan A minus B is equal to tan A minus tan B over 1 plus tan A tan B. So these are the 6 compound angles that we must know about. These are the 6 compound angles that we must be familiar with. They are given in your formula sheet, and you must be able to use them. So I'm just going to quickly share a screen here. I'm going to quickly share a screen. Desktop. Can you see that one? So these are the compound angle formulas, right? So we can use the compound angle formula to expand and simplify compound angles in trigonometric expressions, right? Using the equation from left to right. So these are the cos. Remember, I said cos alpha plus beta. Me, I was using cos A minus B, right? It's cos A, cos alpha, cos beta plus. So you must always try to remember this and try to use it. So remember we are using the textbook Siavula, right? So you must always try to download it and we can work it out together, right? So here, calculate the following without using a calculator, right? Without using a calculator. So what do they mean without using a calculator, right? That's very simple. Let's get back to our paper. So we all know what are the common trig ratios, right? There are common trig ratios that we use every day, that we are familiar with, right? We have the angle 30 degrees, right? We have the angle 45 degrees, we have the angle 60 degrees, and the angle 90 degrees. So sometimes without using a calculator and leaving it in set form, it will be quite easy for you. Let's say you have sine 60. We can write it, if you don't know what sine 60 is, okay, or let's say you have sine, like sine 60. You don't know what sine 60 is, you can write it as sine 30 plus 30. Then you can now use and expand that this is sine 30 cos 30 plus sine 30 cos 30. Now, cos 30, if you're going to be leaving it in set form, what is cos 30 in set form? So you come, though we are not allowed to use the calculator, I'm going to use the calculator for you, for those who don't know. Sine 30 is half, so this is half. Cos 30 is root 3 over 2 plus half times root 3 over 2. So this becomes root 3 over 4 plus root 3 over 4, right? Which I can now add and say this is equal to 2 root 3 over 4, which is equal to root 3 over 2. If I come here and say sine 60, I get root 3 over 2. You see? So we can use this as well to find without using a calculator. Because these trig ratios are common, like I said, 30, 40, 60, and 90. They can be expressed in set form. So this is known as set form. But if you convert it, you can put it in decimal form, which is also okay. But leaving it in this, but in decimal form, you would have to round off. But this is a set form, or we call it exact form, right? So that's for today. That's where we end. If you've got any question, please feel free to ask questions so that we can. Okay, I was not in the chat. Okay. Yes, say it is equal. Okay, I see people were following the lesson. So that's basically. So you must know how to apply your 3 formulas. Your 6 identities. Right? You must know to apply. At this stage, deriving them is not important, but you must know how to apply your angles so that they can give you the correct answer. So when we get back tomorrow, we are going to solve equations using the identities of compound angles, and later on you shall get to know that these angles are the ones that derive as the double angle, because double angle now it will be just writing as if it is tan A plus B. Now I'll be writing tan A plus A, which is equal to tan 2A. Right? That is what we'll be doing later on. But today we end here. Thank you for joining our lesson. Let me quickly share the screen again. I'm going to quickly share the screen again so that you are able to see. Okay, it's exercise 4 on the textbook Siyavula. The textbook Siyavula, you can get it online. You can download it for free, right? So you can actually without using a calculator, you can prove the identity, sign A, right? But firstly, just do question number 2. Just trying to do it in set form to see do you get to the same answer, right? So we continue tomorrow with the same topic. If you've got any questions, please feel free to ask, and I can post them on our chat. I'll be able to see and be able to help you. Thank you.